Hello friends, welcome to Learner's Planet. Friends, this is our second session for factorization of polynomials by factor theorem. Okay, in our previous session we have discussed some good number of problems based on factor theorem, and we did problems of factorization. Now in this session we'll be taking some more problems based on factorization by factor theorem. So let's begin this session. Now let's see this question. Here the polynomial, let's assume it to be f of y. So fy is 2y cube minus 5y square minus 19y plus 42, and we have to factorize it. Now what is the first step? Just write down the factors of 42. That is the constant term. These are plus minus 1, plus minus 2, plus minus 3, plus minus 6, plus minus 7, plus minus 14, and plus minus 42. Okay, now first of all let's check for y is equal to 1. Just put the value of y as 1. So f of 1 is y cube will be 1 only, it's 2, then it is minus 5 minus 19 plus 42. So it is not equal to 0. That means we are putting y as 1 and we are not getting 0. That means y minus 1 is not a factor. Now I put y as 2. So let's calculate f of 2. So it's 2 into y cube will be 8 minus 5. Y square is 4 minus 19 into 2 plus 42. So it's 16 minus 20 minus 38 plus 42. Okay, so 42 plus 16 is 58 and it is minus 58. So we are getting 0. That means if we put y is equal to 2, we are getting 0. That means y minus 2 is a factor. Okay, now let's find the remaining factors. Just mention that y minus 2 is a factor. Now I divide this polynomial, that is 2y cube minus 5y square minus 19y plus 42 by y minus 2. So let's start. 2y square into y is 2y cube. 2y square into minus 2 is minus 4y square. Let's deduct it by changing the sign. So it's minus 5y square plus 4y square is minus of y square. Then minus 19y plus 42. So to get minus y square, we have to multiply this by 2 minus y. So it's minus y into y is minus y square. Then minus y into minus 2 is plus 2y. Solve it by deducting. So it's minus 21y. I write it over here. Minus 21y, and then take 42. So just multiply this by 2 minus 21. So we'll be getting minus 21y. And minus 21 into minus 2 is plus 42. So we are getting 0. That means we got the factors of f of y as y minus 2 and 2y square minus y minus 21. This is a linear factor and this is a quadratic factor. Now we have to check whether this quadratic polynomial can further be factorized or not. So let's check. Now let's try to factorize it. It's 2y square minus y minus 21. Now this is a quadratic polynomial, and we have to choose two numbers whose product is minus 21 into 2, that is minus 42. Okay, here the coefficient of y square is not 1. So whatever the coefficient of y square into the constant term, we have to find as the product of two numbers. That means the product of two numbers must be minus 42 and their sum must be minus 1. So this is product and this is sum. Okay, so we can choose two numbers as 6 and minus 7. So if we multiply both of them, we'll be getting minus 42, and if we add, we'll be getting the sum as minus 1. So let's write minus y as 6y and minus 7y. So it's 2y square minus 7y plus 6y minus 21. Okay, now from this we can take y as common. So we'll be getting 2y minus 7. From this we can take 3 as common. So it's 2y minus 7. Now take 2y minus 7 as common. So we are left with y plus 3. Okay, so we have done factorization of 2y square minus y minus 21 into 2y minus 7 and y plus 3. So finally, the given polynomial can be factorized as y minus 2, y plus 3 and 2y minus 7. Okay, isn't it so easy? You just practice 5 or 6 sums, you'll feel it's very easy. Okay, now let's factorize this polynomial. Let it be fx, x cube plus 13x square plus 32x plus 20. Now let's find out the factors of constant term, that is 20. It's plus minus 1, plus minus 2, plus minus 4, plus minus 5, plus minus 10 and plus minus 20. Now friends, you have to observe one thing, that every term in this polynomial is positive. So if you put any positive value of x, it can never give a 0. Okay, so we should not try with the positive values of x. So let's begin with the negative values of x. First of all, let's take the value of x as minus 1. So f of minus 1 is equal to minus 1 cube, that is minus 1. Then it is 13. Then 32 into minus 1 is minus 32 and it's plus 20. So 20 plus 13 is 33 and it is minus 33. So we are getting 0. That means if we put x is equal to minus 1, we are getting 0. That means x plus 1 is a factor. Okay. Now we can divide this expression by x plus 1. Now let's divide this expression by x plus 1. So to get x cube, we have to take x square as the first term of the quotient. So it's x cube. Then x square plus 1, x square into 1 is x square. Just deduct it. It is 12x square plus 32x. So we have to get 12x square. So let's multiply it by 12x. So 12x square, 12x into 1 is 12x. Deduct it. 32 minus 12x is 20x and this is 20. So further it is 20. So 20x plus 20, after deducting, we'll be getting 0 as remainder. So we have factorized x cube plus 13x square plus 32x plus 20, and we got factors as x plus 1 and x square plus 12x plus 20. Okay, now this is a quadratic polynomial which can further be factorized. Now we have to choose two numbers whose sum is 12 and product is 20. So we can choose 2 and 10. Okay, so let's break 12 into 2 and 10. So x square plus 2x plus 10x plus 20. So it's x plus 2 plus 10 x plus 2. So finally it is x plus 10 and x plus 2. So we got the factors of x cube plus 13x square plus 32x plus 20. And these are the factors. Okay. So x plus 1, x plus 2, x plus 10 are the factors of this polynomial. I hope you are clear. Now let's factorize this biquadratic polynomial. First of all, we have to find out the factors of 6. These are plus minus 1, plus minus 2, plus minus 3 and plus minus 6. Okay, let it be fx. So fx is x4 plus x cube minus 7x square minus x plus 6. Now let's put the value of x as 1. So f of 1 is equal to 1 plus 1 minus 7 minus 1 plus 6. So it is 8 minus 8, 0. So if we put x is equal to 1 in this polynomial, we are getting 0 as a remainder. That means x minus 1 is a factor. Okay, so we got one factor as x minus 1. Now let's put the value of x as minus 1 in this expression. So f of minus 1 is equal to 1 minus 1 minus 7 plus 1 plus 6. So it is 6, 7, 8, 8 minus 8, 0. Okay, that means if we put x is equal to minus 1 in this expression, we are getting 0 as remainder. That means x plus 1 is also a factor. So I just write all the factors over here. X minus 1 is a factor, and now x plus 1 is also a factor. Okay. Now let's try for x is equal to 2. So f2 is equal to 2 raised to 4 plus 2 cube minus 7 into 2 square minus 2 plus 6. So it's 16 plus 8 minus 7 into 4, 28 minus 2 plus 6. So 16 plus 8, 24, 24 plus 6, 30, and 30 minus 30, we are getting 0. That means if we put x is equal to 2 in this polynomial, we'll be getting a 0 as a remainder. That means x minus 2 is also a factor. Okay, so I just write it over here. Now, before proceeding further, just try to find out which can be the fourth factor. Okay, now here as of now the constant term is minus 1 into minus 2, that is it's 2. Now we have to find the constant term as 6. So by which number we should multiply 2 to get 6, that is 3. Okay, so the fourth factor can be x plus 3. Okay, so if x plus 3 is the fourth factor, we can get the desired constant term, but we have to show the working. So let's put the value of x as minus 3. So f of minus 3 is equal to minus 3 raised to 4 plus minus 3 cube minus 7 into minus 3 square minus of minus 3 plus 6. So it's 81 minus 27, then it is minus 63 plus 3 plus 6. So we are getting 0. That means x is equal to minus 3. If we put, we are getting 0. That means x plus 3 is a factor, and this is working of the same. So we can factorize this expression as x minus 1, x plus 1, x minus 2, and x plus 3. Since it is a fourth degree polynomial, we are getting 4 factors of it. Okay, I hope you are clear. Now further, we have a biquadratic polynomial. Let's factorize it. Let's this polynomial be fx. So it's 4x4 minus 12x cube minus x square plus 27x minus 18. And the factors of 18 are plus minus 1, plus minus 2, plus minus 3, plus minus 6, plus minus 9, and plus minus 18. Now, as a very first step, let's put the value of x as 1. So, f of 1 is 4 minus 12 minus 1 plus 27 minus 18. So, 27 plus 4, 31 minus 31. So, we are getting 0. So, if we put x is equal to 1 in this polynomial, we are getting 0 as remainder. That means x minus 1 is a factor. So, I just write the factor x minus 1 over here. Now, I put the value of x as 2. So, f of 2 is equal to 4 into 2 raised to 4 minus 12 into 2 cube minus 2 square plus 27 into 2 minus 18. So it is 16 into 4, 64 minus 8 into 12, 96 minus 4 plus 54 minus 18. So we are getting 0. Okay. So if we put x is equal to 2 in this expression, we are getting 0. That means even x minus 2 is a factor. Okay. Now let's proceed. Friends, we have to observe one thing very carefully, that in this case, the coefficient of x4 is not 1, but it is 4. Okay. So the remaining factors must contain the coefficient of x as either 1 or maybe either 2 or 4. Okay, so without going for more hit and trials, let's divide this expression by this expression. And now this x minus 1 into x minus 2 is x square minus 3x plus 2. So if we divide this by quadratic polynomial, we'll be getting a quadratic polynomial which will be factor of it. And it will be very easy for us to factorize a quadratic polynomial. Okay, so since these are the factors of this polynomial, we can multiply them and we can make a quadratic polynomial. So let's divide this polynomial by this polynomial. So it's x square minus 3x plus 2 as divisor and 4x4 minus 12x cube minus x square plus 27x minus 18 as dividend. So in the very first step, we want 4x4 and we have x square. So we can multiply x square to 4x square, so we can get 4x4. So 4x square into x square, it's 4x4, and the remaining division we have to perform as if we have done in the previous cases. So 4x square into minus 3x will be getting minus of 12x cube, and similarly 4x square into 2 is positive 8x square. Now let's deduct it. Change the sign. So this will be cancelled and even this will be cancelled. So we are left with minus of 9x square. Now let's take 27x and 18. Okay. Now I can write minus 9 over here. So minus 9 into x square is minus 9x square. Then minus 9 into minus 3x is plus 27x, then minus 9 into 2 is minus 18. So both the terms are same, so we'll be getting the remainder as 0. That means we have factorized this expression into these two factors. Okay, so just a moment. Now finally we are having two quadratic factors of that particular polynomial. This was x minus 1 and x minus 2, because by multiplication of these two factors we got this. Now we have to factor this. So you might be knowing the algebraic identity, that is x square minus y square can be written as x minus y into x plus y. So it is 2x whole square minus 3 square. So it's x square minus y square. So we can write it like 2x minus 3 and 2x plus 3. Okay, so we factorize that fourth degree polynomial into these four factors, that is x minus 1, x minus 2, 2x minus 3 and 2x plus 3. So you should be clear about the various methods. So whatever the method is convenient, that can be applied. Okay, I hope you are clear. Now further we have a biquadratic polynomial with us. Let it be fa. So fa is equal to 3a4 plus 28a cube plus 87a square plus 98a plus 24. Further, just observe one thing very carefully, that all the terms are positive. So if we put any positive value of a, we cannot get 0. That means we have to take only negative values of a. And what are the factors of 24? We are just writing the positive factors of 24. So it's 1, 2. I'm sorry, we have to take negative factors of 24. So these are minus 1, minus 2, minus 3, minus 4, minus 6, minus 8, minus 12 and minus 24. So first of all, let's put the value of a as minus 1. So f of minus 1 is equal to 3 minus 28 plus 87 minus 98 plus 24. So it is not equal to 0. That means a plus 1 is not a factor of this polynomial. Now let's put the value of a as minus 2. So f of minus 2 is equal to 2 raised to 4, that is 16 into 3, 48 plus 28 into minus 8 plus 87 into 4 plus 98 into minus 2 plus 24. Okay, so it's 48 minus 224 plus 348 minus 196 plus 24. So let's calculate this. So we are getting 0 by this calculation. That means if we put a is equal to minus 2 in this polynomial, we are getting 0 as remainder. That means a plus 2 is a factor of this polynomial. Okay. So now we have to find out the next factor. Now let's put the value of a as minus 3. So f of minus 3 is equal to 3 into 3 minus 3 raised to 4, that is 3 raised to 4 plus 28 into minus 3 cube plus 87 into 9 plus 98 into minus 3 plus 24. So it's 81 into 3, 243 minus 27 into 20 is negative 756 plus 87 is 783 minus 98 into, so it's 294 and then it is plus 24. So now let's calculate this. So we are getting 0. That means if we put a is equal to minus 3 in this expression or polynomial, we are getting 0. That means a plus 3 is also a factor. So a plus 2 is a factor. Similarly, a plus 3 is a factor. Now, same as previous question, since the coefficient of a is a raised to 4 is not 1 but it is 3. So in the remaining factors, there are chances that the coefficient of a should be or will be greater than 1. Okay, so further repeat the process as we did in the previous question. Let's be it a quadratic polynomial and divide this biquadratic polynomial by this quadratic polynomial. Okay, now let's see how. Now by multiplying these two linear polynomials, we are getting this quadratic polynomial, and we are dividing this biquadratic polynomial by this quadratic polynomial. Okay, now let's begin. It's a square over here, and to get 3a4, I must write 3a square as the first term of the quotient. So 3a square into a square is 3a4. Now 3a square into 5a is 15a cube, and 3a square into 6 is 18a square. Now let's deduct it. So 28 minus 15 is 13a cube. Then it is 87 minus 18 is 69a square. Now let's take the next term. It's 98a. Now as the next term of the quotient, it will be 13a. Now 13a into a square is, it will be positive 13a. So 13a into a square is 13a cube. 13a into 5a is positive 65a square. Then 13a into 6 is 78a. So let's deduct it. Now 69 plus 65 and it is 98 minus 78, that is 20a. Friends, I'm really sorry, it is positive 69a square. So 69 minus 65, it will be only 4a square. Then it is plus 20a, then it is plus 24. Now if I multiply it by 4, so 4a square plus 20a plus 24, the entire term will be cancelled and will be getting 0. That means we have got further a quadratic polynomial as a factor of this biquadratic polynomial. Okay, just a moment. Now we are having two quadratic factors. It's this and 3a square plus 13a plus 4. Now a square plus 5a plus 6 can be written as further a plus 2 into a plus 3. Now we have to see whether this quadratic polynomial can further be factorized into two linear polynomials or not. So let's see. So we have to factorize this, and we have to see that the product of two numbers must be 4 into 3, that is 12, and their sum must be 13. So we can have two numbers as 1 and 12. So their product is 12 and sum is 13. So it's 3a square plus 12a plus 1 plus 4. It's a plus 4. So 3a, a plus 4 plus 1, a plus 4. So it's continued. So finally we are getting a plus 2, a plus 3, 3a plus 1 and a plus 4. Okay, quite lengthy sum. Then but it is very easy. You just have to be careful about the calculation while solving these sort of lengthy sums. Okay, I hope you are clear. Now let's take one more biquadratic polynomial. Let it be FA. So FA is a raised to 4 plus 2a cube minus 2a square plus 2a minus 3. Now let's write the factor of constant term. These are plus minus 1 and plus minus 3. First of all, let's calculate f of 1. It's 1 plus 2 minus 2 plus 2 minus 3. So it's 3 minus 3, 0. That means if we put a is equal to 1, we are getting 0. That means a minus 1 is a factor. Okay. Now let's put a is equal to minus 1. So f of minus 1 is equal to 1 minus 2 minus 2 minus 2 minus 3. So we are not getting 0. That means a plus 1 is not a factor. Now let's put the value of a as 3. So f of 3 is equal to 3 raised to 4 plus 2 into 3 cube minus 2 into 3 square plus 2 into 3 minus 3. So it's 81 plus 27 into 2, 54 minus 9 into 2, 18 plus 6 minus 3. So we are not getting 0. That means a minus 3 is not a factor. Okay, now let's calculate f of minus 3. So f of minus 3 is equal to minus 3 raised to 4, that is 81. Then minus 3 cube is minus 27 into 2 minus 54. Then 9 into 2, 18. Then 2 into minus 3, minus 6, and then minus 3. So we are getting 0 in this case. That means a plus 3 is a factor. Earlier we got a minus 1 is a factor. Now we are getting a plus 3 as a factor. Now there is a tedious situation over here. We are just having 4 choices with us to get this as a constant term. And out of these, 2 are already eliminated. That is, if we put f is equal to 1 or 3, we are not getting 0. I'm sorry, if we are putting a is equal to minus 1 and a is equal to 3, we are not getting 0. And we are left with only 2 options now, that is a is equal to 1 and a is equal to minus 3. But since this is a biquadratic polynomial, 2 more factors should be there. Okay, so let's try to find it out whether they are existing or not. So what we do is we'll divide this biquadratic polynomial by the multiplication of these 2 factors. Okay, let's wait. So we multiplied a minus 1 and a plus 3, and we are getting a square plus 2a minus 3. Now we just divide this biquadratic polynomial by this quadratic polynomial. It's a square plus 2a minus 3. So to get a4, we have to multiply this by a square. So a square into a square, a4, and then a square into 2a will be 2a cube. Then a square into minus 3 will be minus 3a square. Now let's deduct it. So it will be cancelled and even it will be cancelled. And we are left with a square plus 2a minus 3. That means we are left with the same term. So if we multiply by 1, we'll be getting the same term. That means the remainder is 0. That means if we divide this expression by this quadratic polynomial, we are getting a square plus 1 as a quotient. That means the factors of this biquadratic polynomials are this and this. So a square plus 2a minus 3 was a minus 1 into a plus 3, and this is the last factor. Okay, so here there are two real factors and two unreal, or we can say imaginary factors. So the factors of this biquadratic polynomials are these. Okay, friends, I hope you might have enjoyed the session, and you must be doing the problems with me, and now you find yourself comfortable in factorization through factor theorem. Okay, so do revise this session and the previous session. Bye bye.